everyone for joining. As a reminder, the public webinar series is designed to educate attendees on the scientific ecosystem, and each month we'll have a representation from a different coordinating center or a training center, etc., along with new developments for the centers that support them. Today, I'm going to start off by sharing some KC scientific updates, general CFDE updates, upcoming events, and then we'll hear from our featured speakers. Just want to remind everyone again that we have our YouTube channel, which has all of the previous webinar recordings. It's accessible via this link here. Just a reminder, this will be recorded for any of the colleagues who weren't able to attend today, and you can also share with them as well. Just a reminder, we're actively working on site updates, and a few of them are already live at the KC. So if you head to cfdeknowledge.org, you'll see we have this brand new landing page. As you can see here, we're working on some updates to the foundational knowledge pages. And we have two brand new analyses, the gene set analyses and differential expression. We actually have a mini release that's coming up towards the end of the year that'll feature a couple new cards on our various pages. So please keep an eye out for that as well. And as always, if you have any feedback or questions or would like to just be added to our listserv, please email us at help@cfdeknowledge.org. Oops, sorry, went a little too fast. One event that I just wanted to showcase was earlier this November, we attended a large conference in genetics and genomics, and that was the American Society of Human Genetics in Denver, Colorado. These are some pictures that were taken from our various events. We have a lot more where these came from, but we just wanted to highlight some of them. We had our first official CFDE collaborative booth, and this booth served as a place for us to feature different DCCs, including GTEx, MotorPack, the centers, and CEFDE as a whole. We were able to promote the different partnerships, and it also served as a meeting place to further science. As you can see in this picture here, there was one day that we had so many people just coming over to talk science with us, which was a really cool opportunity, and it's always nice to see that as we host these events with that in mind. In addition, our ancillary session, A Human Geneticist's Guide to the Common Fund Data Ecosystem, was so successful. We're going to be recapitulating this presentation and sharing it through this webinar series in the future. So be on the lookout for that, as we're very excited to have a part 2 in 2025. So with that being said, today's webinar is going to feature Bernard de Bono from COMPA and MetaCell's Stephen Larson. They're going to discuss how users can develop and market scientific tools. And one thing that I just wanted to highlight is this is MetaCell's homepage. I'm sure Stephen will go into it a little bit, but if you're interested in taking a look at MetaCell yourself, here is the site. And with that, I'll be handing it off to our speakers. And as I said before, please feel free to ask questions, raise your hands. I'll be monitoring both of these as we go along in our session today. All right. Thank you.
Right. So shall I start?
Absolutely. Yeah.
Thank you so much. Can you see my screen?
Yes. Thank you.
Wonderful. So hello, everyone. My name is Bernard de Bono. I'm co-PI on the knowledge core for the Spark DCC within the Common Fund Data Ecosystem. It is my great pleasure to offer you a quick tour of the COMPA partnership, and I will soon also hand off to Stephen, who will take us through some of the lessons learned from this rather interesting partnership. So COMPA is a partnership of 8 DCCs with, of course, MetaCell driving momentum in an executive role. And as a team, we are dedicating to advancing the mission of the Common Fund data ecosystem. And in particular, our mandate is to bridge the gap between product developers and the broader scientific community to ensure CFDE's tools are accessible, impactful, and aligned with evolving user needs. So COMPA is motivated by a central challenge: improving accessibility and adoption of the CFDE's impressive array of resources. These tools range from data products to analytical pipelines, and they hold, of course, transformative potential for accelerating research, fostering collaboration, and driving innovation. However, Their true value hinges on their dissemination and integration into everyday research workflows. And of course, as we all know, external users lack awareness and understanding of these resources in the main, while conversely, developers face limited feedback on tool utilization. And addressing this disconnect is at the very heart of COMPA's mission. So, to this end, in collaboration with the NIH team, we moved from generic plans to piloting tangible market research on 3 representative CFDE products, namely the previous version of the CFDE portal, the RNA-seq pipelines from both GTEx and HubMap, and the ReproTox knowledge graph. So our strategic approach revolves around 3 key pillars, namely user profiling, outreach itself, and internal gap analysis, all again carried out in tandem with our MetaCell partner. For user profiling, we began by working with the CFDE product developers to understand their tools, their user base, or at least their intended user base, and of course, adoption challenges. And through focused interviews, we mapped potential user communities and identified key scientific gatherings to target for our outreach phase. And this groundwork informed the creation of short demo videos showcasing CFDE tools, which became central to our outreach efforts. For outreach per se, we initiated one-on-one interviews with potential users for the 3 products to gain product-specific insights. And despite challenges in securing interviews, so it was an immense logistic operation per se, we've completed significant ground with valuable feedback, and we're almost 90% done at this point. Each session included pre and post-exposure assessments to elicit insights into awareness and applicability of the individual products. And for the gap analysis, these took the form of internal group discussions to identify areas of improvement for these products. For example, findings included metadata management challenges in the CFDE portal, some branding issues for the ReproTox knowledge graph, and modularity-related shortcomings in the RNA-seq pipelines. But looking forward, we aim to finalize our outreach by year-end and produce a comprehensive report in the first quarter of next year. But in the meantime, it would be great to hear from MetaCell about some of the insights already garnered from this concerted outreach effort, and would very much welcome some of their reflections about cost-benefit strategies for targeted feedback and market validation. And with that, Stephen, over to you.
Great. Thank you both, Mackenzie and Bernard, for the introductions. I will take over the presenting now. I think you guys can see my screen.
Yes,
yes, indeed.
Okay, awesome. And I think you're seeing my whole screen, huh?
Yes, it looks like that.
Okay, maybe I will switch to just the one window. That's better. Okay.
That looks great. Thank you.
All right. So, it's a pleasure to get to talk to this group. Everybody here, if you are part of this common fund, has an interest in the sharing of really valuable data that is necessary for the kinds of insights required to move forward biology and human health. And I think that charged with that awesome responsibility of trying to gain insights into how biology works, right? Taking a moment to think about ensuring that our efforts to get data out into the world are done as well as possible, right? That are the most effective as possible. It's worth taking that time, I think. And so I hope to not overwhelm you with ideas today, but to leave you with something that you can take away that makes it a little easier for you and for the people that would like to take advantage of the data that you're collecting to meet in that. And so we'll talk a little bit about some data-driven strategies for developing and marketing scientific information resources. As McKinsey mentioned, our company has been working on this. We've been in business actually for 13 years now, and I've co-founded the company really with the observation back in 2011 that this exact thing that we're going to talk about today is a hard problem. I built resources as a graduate student in neuroscience immediately prior to beginning this company. And prior to being in grad school, I had done work building software systems in industry briefly and had a computer science background. So I could see the problem really upfront, that there are lots of challenges in doing this. So over the course of the last 13 years, we've had the great opportunity to work on scientific resources that span the gamut of data types. So we started working in computational neuroscience. That originally meant working with more model systems data, whether it be worms, flies, mice, and then eventually humans. We graduated to humans, worked with more like MRI data, human health data, that sort of thing. But we've, throughout the years, been able to work now across scales. And so we've really seen a wide ecosystem that emerges that can be very dependent on exactly what type of data you have. But we've also had the now experience to see what's common across these different data sets. And I want to tell you a little bit about that today. Also, just to give you a sense of the breadth of where today's presentation is coming from. We've had the opportunity to work not only with academic labs, but also with industry customers. And some things we do a little bit differently when we're working on the industry side compared to when we're working on the academic side. But the industry side definitely gives us the perspective of users that need to have resources that are working very well for them, that are well documented, they're easy to consume. And so when we build things on that side, some of the lessons that we'll talk about here are very easy to implement because folks on the industry side are very motivated to have them from the jump, because maybe they're looking to sell a commercial product. Still to scientists, still in a scientific way, but that less often motivates us on the academic side. There we tend to be more focused on things like correctness and novelty and it's all good. But yeah, over the years, we've worked with big pharma, we've worked in the nonprofit sector, with foundations like Chen Zuckerberg, the Allen Institute, and then we've worked internationally, with both US, EU, Asia Pacific organizations and institutes. So it's been great, but it does give us a lot of examples and to draw from. So what I want to touch on today, I'm going to start with thinking about the challenges of user adoption. Some of this language here it's not a thing you take a class on in graduate school. It's not really a thing that you learn. So I will be drawing from language that really does come more from the space of software product management. So user adoption, right? But I think it's important and instructive to get enough of that, even as scientists collecting data, because it opens up a way of thinking. So we'll talk about that. We'll talk a little bit about some of our approach and experience. We'll talk through some effective engagement strategies, user engagement strategies. So how do you engage users, not maybe at the end when you're done, polishing up a resource and then you're like, now people use it, but maybe earlier in the process, maybe even when you're starting the process, maybe even when you're writing the grant. I will share with you quite a bit of survey data that we collected in the context of this COMPA project. And we won't be focusing on any individual product specifically, but I'll walk you through what we learned from the about 26 folks that filled out surveys that were just telling us about themselves and what they like to use and not, and how they interact with the world. Now, they're going to be a particular slice of scientists, but I think by stepping through this, it helps us to orient outside of ourselves and like, I have this data and I want to give it to the world. And instead turn that around and to think about it from the perspective of how would I be perceived, by others that I might want to have use this data. And then we'll just wrap up with some recommendations and key takeaways. So let's start with, some of the high level lessons before we dive into data that like are kind of qualitative that we've observed both from working in COMPA, but just also in general when we're looking at the academic space. And so why do users hesitate to adopt new tools? I think we always like to be optimistic and think that like our tool is going to be the best thing since sliced bread, and everybody is going to look at it and they will immediately realize the value because maybe I leveraged a new technique that wasn't there before. It's a novel data set. I got the grant to create it. Like, why wouldn't anybody in their right mind, immediately understand the value of this thing? But the truth is that until people are, fully oriented to what you have to provide, there is resistance. Okay. And so the more that we think about that resistance at the beginning, the better we'll have luck in getting our scientific tools adopted. And one is that, for postdocs and PIs, there is a resistance to change. When you're thinking about probably the people that you'd most like to have using your tools are the people that are towards the more senior end of the academic, world, the postdocs and the PIs. What we find is that very often they are already pretty set in their tool chains, their workflows, the data sets that they like to use. Of course, they're open to, evolving and seeing new things, but there is a hesitance there that's just based on where they are in their careers. What we have found in contrast, though, is that undergraduates and new graduate students tend to be more flexible adopters. So when you're thinking about getting into a lab, although you want, PIs and postdocs actually starting with the graduate students and the undergraduates first, to then maybe gain excitement and interest to then bring to postdocs and PIs and nudge them and influence them is potentially better. So that tends to influence when you're thinking about like where to talk about your tool or, who you might present it to, right? You might want to go to places where, graduate students hang out, maybe in the graduate programs is a thing to think about because they tend to be in that period of scientific discovery where they are, excited to learn and be sponges. So there is this importance also that I'm going to flag of easy to understand resources. Now, this was a big observation for me, even starting, MetaCell, was that, throughout grad school, the tools and the data sets that I wanted to use, I was realizing that like my computer science background was essential because I was frequently running into challenges of understanding the resource that I wanted to use. And so being able to like write a quick Python script to shift something into a mode that I could actually use was helpful. But I also realized like not everybody had those skills or will have those skills. So things that are easy to understand from the beginning are important. And it's can be a real lift to make very niche scientific resources easy to understand at the same time, right? Like, let's just accept that that's actually a hard problem. It's not obvious how to make your resource easy to understand. We talk a lot in this space about the curse of knowledge. Okay. And, parallel to this, I think happens in teaching. Okay. When you are the expert and you've been doing this for decades, you have forgotten what is hard. You have forgotten what someone who has not the experience that you have, how they look at the thing that you're trying to present to the world. And this is the curse, right? You have forgotten how to lift people up to understand where you are. And it's a very similar thing in teaching. And you have to kind of combat it actively to say, you're coming from a first graduate student level perspective and you're smart and you have basic skills and intelligence, but you don't know these things about my data and you don't know these things about where it fits in and you don't know why this is important and why it's the first thing since sliced bread. So to get to easy to understand requires you to confront your own curse of knowledge and to take a step back and realize that you need to kind of explain to somebody like they're five in the classic ELI5 idea, in order to take a step down from your own knowledge base and, slow down so that you can lift somebody else into your resource. And so we'll talk a little bit about some of the ways to embed that in a data resource, but that's the principle. Okay, and then lastly on this point, I'm going to talk about the need for tools to align with community workflows and expectations. So there are conventions that crop up in scientific communities, and there are sort of existing popular tools that people already use that just create user experience expectations. And they differ depending on what area you're in. But, in spaces like, MRI for a long time, and maybe still to some extent, like the tool AFNI was like the way that a lot of students and researchers interact with MRI resources. And so any new tool that talks MRI needs to be aware that that is most people will know that as the starting point. And so how people even navigate a data set, right? Like the colors that are chosen to highlight, certain things visually, making reference to things that people already know is helpful. So getting a bit of a sense of what are the other tools in the space, and what are people going to think about first at a gut level the first time that they might look at your data, how is it connected to other things that exist, are also very helpful for overcoming the challenges of scientific tool adoption, so that maybe your thing actually just looks like 1 or 2 steps removed from a thing that people are already familiar with, right? It's a risk and a danger to think that because you have a new data set, that the way that you present it needs to look completely different than everything else that ever existed. I mean, maybe, but more often than not, having analogies to things that have already existed smooth the path to people kind of getting it and then getting in there and using your data and making the most of it. Okay, so how can you come to understand what expectations might be in there? Ideally, you're already participating in your scientific communities, right? You're doing that at the level of your institution already. You're doing that when you go away to conferences and present posters. You're doing that when you're invited to give talks and you're interacting with your community. But what people less often think to do is to engage those communities before building tools or before releasing data sets that are of high value, and to engage in a way where you're actually putting those tools or those data sets before they're finished in front of your colleagues. And I know why people don't do that. They don't do that because that requires vulnerability, and that requires potentially there being things that are wrong. And we really don't want to do that in science, do we? We really do not want to expose any flaws in what we've done to our colleagues. However, there is a way to do this, okay? And there is a way to do this that will ultimately end up with people using your tools and your data more, which is what we want, right? So, the idea is to sort of co-launch tools with first a small trusted group of collaborators that you are comfortable, seeing some warts and sharing some caveats with first, right? But those initial points of feedback, as early in the process as you can get them, are gold. They're gold for a startup trying to put an app out into the world, and they are also gold for a scientist trying to release some scientific data to a scientific community. In both cases, the feedback that you get from the outside will help you to penetrate the curse of knowledge that you have. Things that you will see when you are looking at this data that are 100% obvious to you, you need outside voices, many outside voices, to confess to you that they do not see that. It is not obvious to them. And so it's very, very helpful. The more community you can build, initially a small, safe group of trusted people, okay? And then over time, largely expanding it, the more that you gain confidence that, most of the issues may be sorted. And so then what we think about in software development and in development of scientific tools is that, it's not just once, okay? You're not just like, hey, take a look. Okay, you give me this feedback. Okay, great. And now I'm done until I release, right? but actually having an ongoing conversation, right? Because, in our perspective, you don't get to perfect in one step. You get it through multiple iterations. You get it through continuous iteration. There's this term agile development that's very popular in the software world. You can think about that as well. It's the idea that you are continually refining, continually improving, and continually going through the loop of gaining feedback on your improvements so that you continue to get closer and closer, perhaps asymptotically, to the product that everybody really likes to use and they understand very well, and that sort of thing. And so, yeah, so I just I just want to make this like a really clear point. There's building in isolation, which is let's take 6 months. Let's work with our one, developer or our one scientist, and then it's going to be as perfect as we can get it. And then let's publish the paper, right? And then let's open it up for peer review. Okay, very common. I get it. I've been there. Okay, no judgment, right? If this is what you've done in the past, but consider that the challenge is later when you're and now I want the scientific community to go use it, but then they are confused. Okay, they're confused by stuff, even though you've gotten the paper out, right? Even though you're maybe moving on, with your project. The value of partnering with communities as you are compiling a data set, as you are building a scientific tool, as you are putting up a website that has some dynamic component of try my thing, it is much better in general, in our experience, to have been in conversation throughout the period of building it, rather than hiding and thinking that you're making it perfect in isolation and then launching it in some big bang to the world. I know it goes against our normal instincts, but maybe with this talk, it changes by a delta how you think about it. So what have we found works well? So combining scientific expertise with user adoption strategies. And this is kind of why we built the company the way we did. We hire PhDs and we hire software people. And so we make teams of these kinds of folks and put them together. You are not necessarily as a lab probably going to do this yourself. And you don't necessarily need us to help you do that. But the way to do it is to think a little bit more like a software company thinks, right? And to do this process of inviting others in while you have your scientific, expertise, to allow yourself to be a little bit vulnerable in letting folks seeing the warts. But then there are some tools, and we took advantage of these tools in some extent after the fact with a few resources that Bernard mentioned, doing interview surveys and workshops for feedback. And so we'll talk a little bit about those. Interview surveys, workshops, they can be a lot of work, especially after the fact, and to do them at scale. But if you started early, right, it could be as simple as an email to your colleagues or a form that you link to at the end of a talk early in your process that says, I'm going to go get this data and I'm going to go put it out, and I think I'm going to put it out in this way. I think I'm going to build a website. I think I'm going to, put the data up on, I don't know, Figshare or this repository, right? And I think I'm going to collect it together like this. It's going to be in a series of spreadsheets, or I don't know, right? If I do that, could you answer these 5 questions on a Google form that I made for no money, right? That sort of say would that be useful to you? Or a free response section, which is if I put this data out, what are the things that would make you really excited to go use it, right? And you just let people give you feedback, right? I guarantee you that if you get 5 people to fill out a survey like that you will learn something about the way they would like to see that data that you didn't think of. Even though you might be the expert in your own data, it's really not about that. It's about how other people will look at your data and what they will find valuable in your data. So even a simple, I slapped together a Google form, 15 minutes before my talk and I threw it on my last slide, and I want you to help me think about how I might release this data to you, can go a long, long way. And then doing it regularly, right, is important. Workshops we'll talk about as well, but that's another really good way to get feedback. Obviously, there's a little bit more that you've already put out in the world. Okay, creating tools that prioritize user needs and align with workflows. Yeah, so that we think about this as a little bit of there's this phrase in software which is called eating your own dog food. I don't know if you've come across it. It's can generate a small disgust feeling before you fully know about it if you haven't heard it. But the idea of eating your own dog food comes from the idea that, dog food is a thing that you go to the store and you buy, and there's it's a product. And by the way, I saw a chat question there, so I'm happy to answer any questions if folks.
No, I was just saying she loves the term.
Oh, loves the term. Okay,
Yeah,
cool. Yeah, eating
it's
a
a
dog
great
food. Okay,
descriptor.
right. So I think you kind of get it intuitively, but it's like dog food is a thing that you buy. It's a product, and then you feed it to an animal, and you have no idea if it's any good, right? And things that we put out in the world are frequently like dog food that you don't eat yourself, right? You're like, I will give this data set to people and they're going to like it because they're going to like it, right? But you don't know personally, right? And so so this idea here of aligning, creating tools that prioritize user needs and align with user workflows, is to say, like, if there is somebody maybe in your lab or a collaborator that you have that actually really needs to use this data, right? It's very helpful for you to work very closely with them as maybe the first cuts of data are rolling out and seeing how they're using it. This could mean, they are integrating it into, a scientific workflow, like, I don't know, like they're writing a MATLAB script and they need to pull in your data, as one step of their analysis, right? And so, that can be a thing. If you are that person, even better, right? If you're like, I'm going to take this data and I'm going to use it to do an analysis, usually have to do this to, get a paper, generate some graphs. But if you can even think about some of the larger features that you're like, oh, I'm sure everybody will love to use that part of the feature, but I don't actually need to use that myself. If you can push yourself to try to use some of the even more exotic aspects of either your data or your tools or your systems, like that's getting to prioritizing user needs and aligning with workflows better, because you can have empathy for the challenges that people will run into. So eat your own dog food. Okay, and then examples of successful MetaCell tools. I'll show you a picture of this first one, virtual fly brain, and then I think I'll just circle back to talk through some of these other ones. So virtual fly brain, I love this example because it's very visual. It's so much in science world, of course, is abstract and buried in numbers and that sort of stuff. But this is dear to my heart because, when I was working on my own dissertation, a system like this was something that I was envisioning being able to do. And it's really a, multi-omics, multimodal, multi-scale visualizer for bringing lots of different data together. The challenge of doing a system like this is really, okay, it looks cool, but who is actually using it for real and what do they need? What I like about this project is that we built the 2.0 version after the 1.0 version had already been released, and the team that built the 1.0 version had all this feedback, okay, from their first set of users that had tried to do stuff in the 1.0 version and were like, I can't get at this data, or I don't understand how this thing works. And so the reason I'm bringing it up here is that we did this 2.0 version really informed by user need and what their workflows really actually needed. And so this is a way, just at a top level, this is like the Drosophila brain, and like 15 different data sets that incorporated different kinds of imaging, that are all aligned together spatially. And then points in space are also, connected to literature data, as well as a regularized ontology that breaks the parts down in different ways. And so we could aggregate information about genomics and morphology, individual neurons, areas of brain, all into one environment. And then a lot of data sets that had been painstakingly collected, that had initially been separated from each other, now can all kind of bear on each other and synergistically create more value for folks. But again, the key is less the data and more that we could do a 2.0 version to bring it to life. The other ones that I mentioned, so open source brain is a computational neuroscience system. You can Google it. We've been working on it for about a decade. It's been one of our oldest projects. And that's another one that because we've been doing it over so much time, we've just had the ability to iterate and iterate and iterate and iterate it and learn from users and learn from users and learn from users. The first version, right, was not, we didn't know what people would want, but it's a system for bringing together computational neuroscience models and actually simulating them in in your browser, so fully web-based, and then being able to connect that with experimental data and compare like neuronal traces with that. NetPine is also a simulator. A lot of workshops for this one we've participated in, whereby we've helped the PI there, have an online experience where it's very easy for folks that are physically together, like at a meeting, to pull up this tool on their own laptop without having to do any installation, and then give feedback in real time about like what makes sense to them and what doesn't. So again, the learning from the user is really important. And then Minion is a kind of on the other side of the coin, a tool for doing data analysis from calcium imaging movies. And that's one where we were invited in, again, to benefit from the fact that like this had already been published. It's somewhat found a community, but there were a lot of bug reports. And then we were brought in to help like stabilize the software base. It's the open source software that basically motion corrects and pulls out traces from neurons. And here, we were taking on the responsibility of making the community much happier with the stability of the tool to have it do all the things that they wanted to do. So I think the theme I'm just trying to get at is that it's not about the tool itself. It's about the process that helps you iteratively improve it at whatever stage, it's put out. Okay. So user engagement strategies, how to engage your users effectively. We've already talked a little bit about interviews and surveys. And here I'm just want to give you some sense of what it takes to do this kind of after the fact, which is what we're kind of doing in COMPA, which is that we're, maybe didn't have as much the advantage of having done this process throughout. So for some of these tools, we're kind of doing surveys now, and we're finding out like how people think about these tools. So we, in COMPA, have started with a list of 5,000 candidates, like scientists, basically, that we could try to reach out to. And then we've whittled that down to about 800 that we've actually essentially sent emails to and said, please, 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 can I borrow a little smidgen of your time to, even though I don't know you, to take a look at some resources that we think are relevant to you because we, looked you up, and, it seems like this is the thing that you might want to use, and we'd really, really appreciate it. And it would do a great service to science, and just asking extremely, extremely politely, right? And then from 800 emails so far, we've got like 26 responses. And you might look at this and like, this is terrible. But actually, in the world of like product marketing and product development, this is pretty good in terms of conversion rates. Okay. But this is what it takes when you're like, I got to do this. And I'm like, people don't know what this thing is like. Much better to do this over the course of time from the beginning. Again, I might be beating a dead horse here, but okay. But we're going to get some interesting insights anyway from these 26 responses. Another way is workshops. A few years back, we did a workshop where we managed to participate in a community that had we got 400 attendees into a webinar. Okay, like awesome. It was during pandemic, so people didn't have as much to do. So I guess that's the caveat. But we got 400 people to show up, and we did like plenaries to talk through. This was for the mini, and it was a virtual Miniscope meeting. And so there were like a plenary session that like walked through like how to use a Miniscope and how would you build one, and think about the lenses and think about the data analysis and all that. And then we also talked about the data analysis in detail and walking through the Minion pipeline with about 30 people separately, where they got to play with the technology at home while they're in sync and getting walked through on a call like this on Zoom. So workshops can be a really valuable way. If you're doing it along the way, it's a thing maybe that you can sneak in, right? Again, when you're talking through your methods, you could be also showing again, some initial, maybe top level observations of what you're finding out so far. And then again, asking people to maybe fill out a few answers to things. And then online presentations is kind of, maybe blurring the lines here between like a workshop where you learn versus an online presentation where you maybe work it into a talk. But obviously, anytime that you're online, it's helpful to reach folks. I guess I'd add to this that, there's the value of the people that are attending in real time, but then there's recording it to YouTube, like a YouTube channel that you own, and then being able to send it to people later down the road to talk about the data that you have and let them engage with that content asynchronously. So these are all ways that you can start to gain more insights. Maybe 2 or 3 weeks down the road, somebody that watched your YouTube video fills out your survey, and then you learn a little bit, later. And then you're refining it and getting better as you go. All right, so let's look at some data. We're all scientists here. We like data. So the first couple graphs I'm going to show you are just kind of level setting, like who did we kind of get a hold of? Okay, like who's responding, so that as you see the rest of the data, you're kind of like level set of like, okay, this is the group. So the largest group that we were able to access by far were postdocs. Okay, and so remember what I mentioned earlier, that like postdocs and PIs and professors like would make up the majority of this group, as well as like postgraduate students and seniors. Like this group of people are probably the hardest to reach. Okay, they're the least open, right? But so take that with a grain of salt. It's like the toughest group: professors, PIs. The postgraduate student, is I think in the space of not exactly a graduate student. So in terms of institutions, 80% of folks are in the US. Okay. We have a few folks in industry as well, but it's a minority for sure. All right. So what do people use public data sets or repositories for? Okay. So I love this, this to begin with, because this is really doing what I said at the beginning, which is you want to orient yourself not to your excitement to put data out, but to understand what people out there want to use. Like, what do they do? What do people use data sets for? Actually, any data set, right? And so it turns out that 26.7% is for initial investigations at the very beginning. I have an idea, I want to flesh it out. Then I go look for data sets that are out there at the beginning. Not like I'm deep in my experiment and then I go use it, right? So it's like very initial investigation. Sort of suggests that in the brainstorming or ideation phase of coming up with experiments, that's when people are most looking around at that part of their investigation. There is, though, a healthy margin here. 16.7% are doing confirmation or replication. So for folks who are trying to replicate results, they really do want to get a hold of, the data set. So that's important. And then the last largest category next is like finding relevant publications. So when folks are looking to compare something that they're doing to what else is out there, they will want to try to get a hold of the data sets. So those are the major categories: initial investigations, confirmation or replication, and then finding relevant publications. So what you could, think about when you're, trying to put your own data sets out is to think about like folks that are in those stages of their scientific journeys and how your data will speak to folks in these different stages. So orienting yourself to folks that are in the brainstorming stage or in the confirmation or replication stage or in the finding relevant publication stage, will be important. How do you access public data sets? Second at the bottom here. How do people do it? They download it from the website 45.2% of the time. This is very frustrating to those of us who build tools that we think are very attractive, like the one that I showed you with the 3D data set, because there we're like, but use our tool because it's cool and it is in 3D. And don't you want to rotate a brain in 3D and, around? And what users say is that 45% of the time, they want to download the data onto their own computer and use it on their own computer most of the time. Note that there's download from website, and then another 6.5% is just download. And then there's FTP downloads, and then there's direct downloads, right? So actually, if you sum up the amount of space here where accessing public data sets involves taking it away from your site and using it locally, it's the vast majority of people want to do that. And I have found this, outside of this survey also. And, it's a challenge. At the same time, it tells you something that if you're going to put some data out there, if you want to make a fancy site that costs money, you want to work with us, we'll make you a very fancy site, great. But always have a download button, right? Always have a download button, because maybe what people will do is first they're going to download it because that's the way they're going to interact with it. But then they're going to be like, oh, I'm having trouble seeing how this data works when I throw it into my spreadsheet or when I'm doing some coding with it. And then maybe they'll come back and they'll be like, okay, how are you visualizing this? How are you putting this together? Right. And then, they'll go. But if they didn't have a download button, they'll probably get frustrated with your whole data set to begin with, and then they'll just go away. And then make sure that your download button returns something pretty easy to use and reasonable, right? Sadly, CSV, it pains me to say as a software engineer, but tends to be the lingua franca even now, right? That people want to start with, Excel spreadsheet, open Excel spreadsheet also, a little bit better, maybe have both. Again, maybe it's not the only thing that they're ever going to use, but folks in general are saying they just want to download that data. And if we're not talking about tabular data, of course, there's many other data sets. There's imaging data, there's electrophysiology data, DICOM files are a common thing. But in general, if you're using some type of data that's not kind of text-based or tabular, just try to have it be downloadable in the most common format or the easiest to use one. I participated in standards groups for the last decade, trying to come up with new standards, better standards, compressed standards, standards, and those are lovely, and I'm a big fans of many of them. But at the same time, the ease of use should be a thing that you absolutely always have, and then provide in some maybe more modern standard after that. So something to think about. The way people tend to access data sets by far is they first just want to download them. And then later, maybe they'll use something on the cloud, or maybe they'll, 20% will call an API. Okay. Probably they'll call the API and then just download the data from the API. But yeah, so that's interesting insight there. All right, let's get a little bit deeper. Do you use publicly available data sets / repositories? So of our respondents, 80% actually do, which is nice. So, it's a good thing to know. Are they using it? 20% don't, at all, it seems. But 80% do. So of this group of respondents, okay, great. So 80% of these people are actually doing that thing. And of those data sets, what attributes are important? Okay. This is what the data say. So the largest sector of this by far is documentation. 22% say documentation. And 13%, there's a tie for the second category between accessibility and relevance. Accessibility, I think, probably just gets back to download. Can I download it? and could I find it, right? But but once I have found the website, can I get at the data directly? Relevance is a little bit subjective, obviously, and that one's hard to see. What's relevant is very often in the eye of the beholder. So that one can be a little trickier to unpack. Then after all those things is the quality of the data. Okay. So interestingly, people first most care that can they understand what the data is by it being well documented? Can I access it? And only then do they start to evaluate the quality of it. And I know that we're all the most concerned about this thing, right? It's like, hey, my data was really great. Yeah, maybe I should have documented it a little bit more, right? Turns out the user would much prefer you to have documentation. And then maybe in the documentation, you can have a caveat and you'd be like, yeah, in some cases, we didn't there was this issue with the data quality, well, we tried to fix it, but honestly, it was this limitation of my experimental method, right? So I think that's an interesting thing that we don't tend to think about. I think we're all dead set on how good the quality of the data is, and we're very less often caring about the documentation and how accessible it is. Okay, so I think those are the main takeaways from there. Last one to mention that's a tie with data quality is complete metadata. Complete metadata honestly goes hand in hand with documentation. So do think about it, Again, these are things that are, go outside the thing we tend to be focused on, that, what the quality of the data are. But if people don't know what the data are, they're not really going to be able to well evaluate the quality of it anyway. So do spend time thinking about that, even if all you're doing is putting a data set on a GitHub repository. All right. And now the last bit of data that I'll share with you guys is, about, this is a bit of a grab bag, but just of this group. And again, this may be more relevant to you depending on what sort of science you yourself are doing, but just of interest. Like we had a very diverse name check of public data sets and repositories that people do use. But there's some indication here of, what resources, are effective that people find are when they are using data repositories, what they're finding are useful to them. And, 13% are doing stuff in geo, and, more power to them. So it's, obviously it's a very important resource. We can question how usable it is, but in this case, they are using it. Some other resources, as you can read here, factor in, but it's pretty evenly distributed. After that, yeah, I think some we might think would be more popular than they are, but this is just reflective of the respondents that we happen to get. And then experimental techniques and technologies, big pie here, CWAS, what folks that happen to fill out our survey are using most often. And you get some, smattering and name check of some other experimental technologies and methodologies. But again, this just sort of tells you like, yep, these are scientists. Yep, they're doing stuff in this sort of bioinformatics space. And so let's kind of take seriously what they say about the accessibility of data. Okay. So I'm almost done here. So just like kind of takeaways from these things, I already mentioned documentation. That's a big one, right? It comes right out of the data. That's important. But some things that we don't always think about though as well, especially when you're building things more than just a GitHub repo. But even then, right? People will expect to be able to get a hold of a human, even if it's just like, can I email the PI from the email address on the paper that I read about your data set? They do expect human support. And it is the tough lesson, right? Because like scientists are not trained to be user support. And it's not part of your job description. And you don't like get to tenure faster by being more responsive to the people that are asking you about your data. But they will expect to. And so just factor that in, right? If you don't think that you can field all the questions that you might get on your paper, like, ask for some help from, your postdoc. Ask for some help from a collaborator who knows your data really well. Self-serve resources here is, a counterpoint to documentation. It is like, ideally, there is no need to read the manual. Ideally, things are intuitive to begin with, right? Intuitive could just mean that your stuff is formatted in CSV with like pretty nicely descripted column headers, right? Like that's one way to be sort of self-serve, that like the column headers are really easy to understand when I downloaded your CSV. That could be self-serve. And then there was like some documentation that like maybe explained what all your columns are in one line, okay? So ideally there's not like, oh, I have to provide 50 pages of documentation that go into every nook and cranny of this thing. At the same time, people want enough documentation that they can, once they dig in, get to some detail. And the last two are online forums and publications. Online forums can be a Google group. They can be a mailman server. They can be a Slack channel. If you participate in a larger Slack community, it can be one channel in a larger one. But places where users can ask questions in a community context can help other users. The issues list in a GitHub repository, if you're putting a data set out, just enabling that can be helpful. And then lastly, the publication, not going to be a surprise to anybody here. It's still a gold standard for providing depth and clarity onto what went on in your resource. So obviously when you get that out there, that's going to be a touchstone for stuff. Okay, I'm running out of time. So finally, just to summarize it up. So I think you probably heard me loud and clear now. I've said it in like every possible way that I can think about, but like try to engage your communities as early in the process as you can. Even if it means being a little vulnerable, you like give yourself room to change what you thought you might produce at the end, give yourself room to adjust. But that adjustment can go a long way to, by the end, having people who have been following your process and cheering for you all along the way to be like, it's finally here. And I got to have a say in how it was going to come out. And now I'm going to go tell all my friends to go check out this resource because I know that it's good because I've been personally involved in it, right? You get buy-in from people, they promote your stuff more. Secondly, understanding the user need is critical in scientific applications. It just is. We like to ignore it. We like to not think about it, but it really is critical to getting your tool adopted. And then finally, the more feedback you can get from your target users early and often, the more likely your resource will be adopted. Yeah, I just said that. So thank you so much for your time. I know I left only like 2 little minutes for questions, but I'd be happy to answer a question from the community in the time that's left.
Great, thank you so much. Again, if you would like to raise your hand to ask any questions, I'll be able to unmute you and then you can ask away. Okay, Julie, you should be able to talk now.
Okay, thank you. That was fantastic. I had a question about the survey results that you presented.
Yes.
Most people said that they prefer to download. How was that question framed? And do you think it was obvious that interacting with the website without download was, an obvious answer that people could have given? And then secondly, do you think that if primarily postdocs were answering this, then they might have been more like computational biologists or something to begin with?
Yeah. So how was it framed? Literally like this question here, like this is like a cut from the Google form. So like, how do you access public data sets? It was just that. And then it was a multiple choice with the ability to fill in other. So some of these answers were like other responses, right? So download, I think, was given. I think, and then there was the ability to fill a few in. I would need to go back and tell you exactly which of these versions of download were pre-given versus were added by folks that were typing them in. So that was how it was framed, pretty open-ended. I'm sorry. And then the second part of your question was?
Okay, that makes sense. I guess the second part is if primarily postdocs were answering these, do you think that you might have had more computational biologists or people like that that were sort of coming to the site to?
In terms of the population, maybe, but yeah, I mean, this again was the same population of folks. So the fact that lots of folks were, using pretty experimental, data-oriented sites like Geo, like 1,000 Genomes, and they're doing things like, I mean, there are folks doing computational approaches, there are folks doing data engineering, but then, there's folks that are running like GWAS and genomic sequencing and high throughput analysis. So yeah, I mean, there's definitely somewhat of a computational bias in this population, I suppose, but I don't think it's exclusively computational people, if that's what you're thinking about.
Makes sense. Thank you.
Yeah, great question.
Thank you. Any other questions? Okay. Thank you so much to both Stephen and Bernard for presenting today. As a reminder, this will be uploaded to our YouTube, so please feel free to share the recording with any of your colleagues. And then just before we go, a reminder that we will reconvene January 31st, so we will not be meeting in December. So just want to say happy holidays and thank you for a wonderful 2024 with the start of this series. So thank you again, and we really appreciate you taking the time today, Stephen and Bernard, to present.
Thank you all for taking the time to listen.
Thank you.
Cheers.
Bye, everyone.